So, what's happening this week? A Harvard 3D exhibit is a PhD in photogrammetry and historic preservation. NASA seeks to safeguard our drones. Construction bots get the top 5 treatment. Digital twins and sustainable design approach peas and carrots status. And an AEC Error of the Week at Denver International in which the only turbulence was with the damn luggage. Boost that GPA or get that transcript forged, recappers. Your lead story's off to Harvard for a 3D exhibit taking breaths away from anyone who loves architecture, photogrammetry, history, mysteries, and innovative approaches to old disciplines. The subject of the exhibit? France's Cluny, the age and story of which place it high in the running to be the GOAT of monasteries. But while Harvard's reality capture and exhibit encompass Cluny rather than exclusively fixate on it, the sacred ruins are no stranger to documentation or even AR by almost 15 years. In 2011, a multidisciplinary team from Arts et Métiers Paris Tech, an engineering institute, please pardon the pronunciation, and CNRS, that's French National Center for Scientific Research, captured Cluny's surviving remains and decorative fragments. They used a ferro polyarticulated arm with a Metris model maker probe to achieve sub-millimeter accuracy for lapidary elements like capitals and friezes. This included scans of fragments from the destroyed Gothic facade, enabling the reconstruction of an 8-meter diameter rose window based on curved stone blocks. The workflow involved merging 1,600-plus scanned files into a unified 3D model, integrating hypothetical elements like choir stalls for 270 monks based on historical records. The team developed real-time AR models and pre-computed simulations, enabling immersive visualization of the nave, portal, and choir. 4 on-site AR terminals allowed visitors to overlay digital reconstructions onto physical ruins, while a 15-minute stereoscopic film contextualized the abbey's original grandeur. By combining engineering, archaeology, and digital imaging, Arts et Métiers Paris Tech established a benchmark in heritage digitization and transformed public and academic understanding of Cluny. As for Arts et Métiers Paris Tech, oh my god, my pronunciation, meh. Nothing big. They've just developed a reputation as big as Cluny at its peak for high-speed machining, digital modeling, and virtual imaging. Straight from a campus on Cluny Abbey. And now, as we'll soon highlight, a different campus on another continent is writing a new chapter of the Cluny chronology, this time commemorating the man who a century ago laid the groundwork. So the next time someone says Cluny looks good, thanks to reality capture, you can one-up them with an even better-looking Cluny. C'est bon! Hit those show notes for some quick caps on Chinese LiDAR recognizing a face from space, Gaussian splatting in Blender, a concrete TED Talk, the 3D scanning traveling metrology team keeping Warfighters airborne, a new study on improving building energy models, and high-fidelity wheat plant reconstructions using 3D Gaussian splatting and neural radiance fields. And we're off. Recap number 1. Photogrammetry honored an architectural historian and resurrected ruins at once. Time is relentless. Great structures rise and fall, leaving behind fragments, some physical, others in memory. Reconstructing the past has always meant relying on sketches, speculation, and the fallibility of human perception. But today, reality capture allows us to turn ruins into digital records more enduring than stone itself. And some Harvard heroics are proving it, while extolling the man whose early 1900s efforts made it all possible. As the Harvard Gazette relays, the college's Envisioning Cluny, Kenneth Conant and Representations of Medieval Architecture 1872 to 2025 exhibition showcases the tale of Cluny III. This colossal medieval abbey once dwarfed Notre Dame, but was nearly obliterated after the French Revolution. While early 20th century historian Kenneth Conant painstakingly mapped its remains by hand, modern Harvardites have built upon his work using photogrammetry, generating hyper-accurate 3D models of the site. Quote, "The exhibit is the story of a man and his passion, which is the Cluny Abbey Church, and how we can experience it today using modern tools," said Matt Cook, Digital Scholarship Program Manager at Harvard Library, who worked closely with curator and architectural historian Christine Smith. Harvard Library Imaging Services employed photogrammetry to transform the plaster cast of the mysterious Cluny columns into the 3D models showcased in the exhibit. This process involved capturing hundreds of individual photographs of each capital cast to generate each complete model. The 3D scans enable Smith and her students to examine the 8 capitals with unprecedented flexibility, zooming, rotating, and reconfiguring their designs in ways unavailable to previous scholars. This offers fresh perspectives on the long-standing mystery of these 8 architectural elements, and fresh gratitude toward the man who awakened us to them. Recap number 2. NASA is ensuring our drones can safely go to infinity and beyond. Late 2024 saw a bunch of mysterious crafts flood the sky. 2025 has already experienced how delicate our airspace can be, and any recapper not new in town knows the profusion of industries with growing drone intrigue. So there's not a scenario in which the skyrocketing of drone flights is not dangerous. It inherently sort of just is, given the inevitable combination of ineptitude and bad actors. But who better to safeguard our drones than the crack techies and pilots of NASA? Probably no one, if this IASMS is any indicator. The aerospace aces are making heavy progress with the In-Time Aviation Safety Management System, which will provide real-time monitoring, assessment, and risk mitigation for operators who may have nada to do with NASA. A key goal of IASMS is to transition safety assurance from a manual reactive approach to an automated proactive system. Good looking out, AI and ML anomaly detection. Quote, if everything is going as planned with your flight, you won't notice your in-time aviation safety management system working, said Michael Vincent, acting deputy project manager at NASA's Langley Research Center. It's before you encounter an unusual situation, like loss of navigation or communications, that the IASMS provides an alert to the drone operator. A number of colleges aided this studies and simulations, from Ohio State and George Washington to Virginia Commonwealth University and Notre Dame. Hey, it's the Flighting Irish. Scenarios range from remote wildfire performance to package delivery in a bustling city. The most promising and perhaps surprising development so far? A 12-pilot simulation framed around hurricane relief and recovery. The pilots operated a fleet of up to 6 drones navigating beyond visible line of sight to get supplies to hurricane victims isolated by severe weather. Supplementary drones flew scripted search and rescue missions and levee assessments. Throughout the exercise, the research team collected data on system viability, pilot performance, mission success, workload, and perceptions of the experiences, all in the name of safer skies, as they will surely get busier. Recap number 3, droids in the dirt. Autonomous robots for construction sites, ranked. The chart of construction robots' expected growth probably resembles that of LinkedIn AI images. Mas. Explosive urbanization and industrialization, safety, an aging construction workforce, and the almighty dollar have catalyzed Conbot desire. The outlet Unite.ai noticed as much and compiled their cream of the construction bot crop into a rigorous top 5 list. In no stated order, it began with Dusty Robotics' BIM processor extraordinaire, the Field Printer, bridging digital building plans and physical execution with 1/16-inch accuracy at 600 dpi. It integrates oh so finely with tools like Autodesk, Revit, and AutoCAD, ensuring precise on-site layout from BIM models. One operator can mark up to 15,000 square feet daily. Skanska USA used the system to cut $3 million in costs and shorten a project by 3 months. With precision hardware, robust software integration, and tools like a collaborative portal, direct BIM connectivity, and an iPad app, Field Printer keeps all stakeholders aligned and on spec. Numero dos, deep robotics quadruped systems, which showcase how embodied AI can take on hazardous, repetitive construction tasks with precision and agility. They use integrated sensors, GPS, and AI-driven algorithms to navigate complex sites, perform high-accuracy mapping, and avoid obstacles better than OJ's legal team. Their real strength lies in automated surveying, processing environmental data to deliver precise, efficient site documentation. With remote operation and smart mobility, they tackle risky environments while enhancing human capabilities through consistent, intelligent execution. Then we got Built Robotics RPD-35, the pile-driving revelation on solar farms. Designed for speed and precision, it installs piles with sub-centimeter accuracy using RTK GPS, IMUs, and laser rangefinders, driving a pile every 73 seconds up to 300 per day with just a 2-person crew. The system's 8-layer safety framework includes 360-degree smart cameras, AI-powered vision, wireless emergency stops, and 24/7 remote monitoring. On large projects, like a 250-megawatt solar park with 100,000 piles, the slashing of time and labor costs is always sunny in Buildadelphia. With automatic as-built documentation and minimal rework, the RPD-35 is the coolest pile driver since the advent of professional wrestling. Incoming at 4 is Civ Robotics and their Civ.Plus, and Civ.Mini. The SIV marks up to 3,000 points or 16 miles of lines daily with uncanny accuracy, using a Trimble R780 GNSS receiver and IMU-based tilt correction to stay precise on rough terrain. For higher precision needs, the SIV Plus delivers 8mm accuracy, marking up to 1,200 points per day. The SIV Mini is purpose-built for line striping. It marks up to 17 miles of solid and dashed lines daily with sub-inch accuracy, turning multi-day jobs into single-shift tasks. Just ask DPR Construction, which cut a 4-day layout to just 4 hours. With preloaded SIV plan software for mission planning and detailed reporting, the SIVs are operator-friendly and don't require specialized training, making high-precision automation accessible to any crew. Rounding out the list is a would-be Olympic gold medalist if rebar tying ever got greenlit. TieBot from Advanced Construction Robotics. Requiring no pre-programming or BIM input to conquer a premier difficulty in construction, it ties over 1,200 intersections per hour with 99% accuracy. A single 15-pound wire spool enables about 3,000 ties, and it handles a suite of rebar types, grid spacings, and slopes up to 30 degrees. Setup is quick. TieBot can start within 2 hours of arriving on site. It's powered by a 7,000-watt generator for 10-hour shifts without refueling and features an intuitive control interface with real-time feedback, making it both efficient and easy to operate. Recap number 4, copy that. How digital twins make sustainable design an easier yes. A perfect circle ain't really achievable in our physical world, and there certainly can't be a perfect circular economy in AEC. But digital twins are getting us closer than ever, mainly through resource management, energy efficiency, and predictive knowledge. Parametric Architecture's recent entry specifies how this only grows in importance each day energy and resources remain finite, not to mention that resource extraction is costly, time-consuming, and potentially sensitive to supply chain fissures. The sizable piece begins with a meticulous 7 steps for optimal twin deployment. Model development, performance data, model calibration, analysis and diagnosis, corrective action, deployment, and finally monitoring. Author Nandini Subramanian then shifts to sustainability-specific benefits, improved design and simulation, material and waste management, enhanced safety measures, and life cycle assessment and optimization. Then come the striking examples of twin sustainability. Subramanian starts with the Morpheus Hotel in Macau of Zaha Hadid Architects. Its exoskeleton was developed using digital twin technology to reduce the amount of steel used. Engineers were able to test different scenarios in crafting the exoskeleton, yielding the most efficient design. Then there's the Suzhou Center in China of the Benoist Studio. This development leverages digital twin tech to predict building performance and occupant behavior, optimizing energy usage. All design decisions stem from digital twin data, enabling environmental impact monitoring and enhanced governance throughout the sustainability lifecycle. The conclusion projects the future of digital twins using McKinsey's 3-horizon model of growth. Horizon 1, the current scenario, is where digital twins prove valuable for sustainable design in specific cases, but require accelerated standards development to realize sustainability benefits. Horizon 2, the near future, is the evolution of connected digital twins. Here, they will expand to city scale, enabling real-time insights and predictive maintenance across broader operations, and optimizing widespread resource usage. The final horizon, the long-term future, should see implementation at the city or national levels. This will facilitate substantial climate action through comprehensive product data, recycling options, and sustainable systems for global scale planning. Can't you just smell the failure, folks? It's time for your AEC Error of the Week. Denver International Airport's automated baggage system. For an airport rife with conspiracy theories, DEN sure could have conspired better in 1995. Toy Story is in theaters. Windows 95 is rebooting the world, and the Mile High Hub is fixing to drop the tech equivalent of tariffs on stock markets. Enter the automated baggage system, a $560 million cautionary tale of innovation outpacing integration, a complex web of unproven tech, siloed stakeholders, a lack of real-world testing, and good old-fashioned hubris. The system promised to whisk 60,000 bags daily through 21 miles of track using 4,000 autonomous carts, but it ended up as a derailed train of malfunctions, misread barcodes, and software crashes that left bags circling the airport like lost souls in a Tetris apocalypse. The system's collapse began with a slew of warnings and fatal misalignment between design and reality. Architects finalized terminal layouts before engineers could map optimal baggage routes, forcing the automated carts to navigate hairpin turns like a bank heist crew on an F1 track. By 1994, the project was already in freefall. A rushed media demo laid bare the chaos. Carts collided at full speed, shredding bags and spewing clothes across tracks. Unproven barcode scanners misread tags, sending skis to Miami and Speedos to Siberia. The software, tasked with coordinating 4,000 autonomous carts, buckled under complexity, triggering system-wide crashes during routine operations. Engineers, scrambling to meet deadlines, slashed cart speeds by 50% to reduce derailments. When the airport finally opened 16 months tardy, the, quote, automated marvel served just one concourse, handling only outbound United Airlines flights. The rest relied on a manual backup cobbled together in desperation. The system was phased out in 2005, replaced by a conventional alternative. The DEN debacle wasn't a failure of technology, but integration. Architects, engineers, and software developers operated in silos, each optimizing their piece while the system crumbled. Modern reality capture tools prevent such isolation, forcing stakeholders to confront shared risks through shared data. Let's tackle a few. Clash detection. BIM could have exposed spatial conflicts between building geometry and baggage tracks, eliminating deadly sharp turns. Digital twins. Simulating cart movements at scale would have revealed software bottlenecks and mechanical stress points, averting real-world carnage. IoT sensors. Real-time monitoring of track alignment and cart performance could have flagged emerging failures, replacing reactive chaos with predictive maintenance. Imagine a world where LiDAR scans of the terminal's skeleton informed iterative track designs, where augmented reality overlays allowed contractors to see baggage routes during construction, where AI analyzed cart telemetry to predict jams before they occurred. The airport's baggage nightmare reminds us. Innovation without integration is just expensive theater. Every scan, sensor, and simulation exist to answer one question. What are we not seeing? Because in AEC, the unseen is where disasters begin. And that is your week's recap, ladies and gents, where reality capture stands, who's advancing it, and the history behind it. Hit those show notes for some quick caps and sources, and we thank you for liking and subscribing, as does this whole glorious industry. Deuces!